Okay, up to this point, every equation that we've solved, up to this point, every equation that we've solved has been a linear equation. And a rule for linear equations was get rid of parentheses, get all the x's on one side, get all the numbers on the other side divided. That was it. Okay, 3 steps. Quadratic equation is a little bit different. And before we go into quadratic equation, let me explain what a quadratic equation looks like. Because we need to know linear versus quadratic. Linear, 3x minus 6 equals 4 parentheses x plus 2. That's linear. Notice what's special about your x's. Okay, look at it. Quadratic. X squared plus 3x minus 4 equals 5x plus 7. There we go. Example of a quadratic equation. Pretty much, linear equations are your basic ones. Quadratic equations is your next step up. And then later on we'll get into, in Algebra 2 and pre-calculus, we'll get into the tougher ones. But all that's different about a quadratic equation is instead of plain x's, somewhere in there you're going to have an x squared. Okay? And anytime you have that x squared, you're going to have to solve it just a little bit different. So that's linear versus quadratic. There are 3 ways that we're going to talk about solving quadratic equations. There are other ways. Okay? These are the 3 best ones. The first way to solve a quadratic equation is by using square roots. The second way of solving quadratic equation is with factoring, and then finally you've got what's called the quadratic formula. Before we go into, well, hang on, I'm not, and y'all don't have to write it. Yeah, before we go into these, let me give you a basic equation. Well, first off, let's make sure everybody understands this. Something raised to the second power. 5 to the second power means we're multiplying 5 times itself, right? What is 5 to the second power? 25. So what if I gave you this problem? And I told you what goes in the box. Let's revisit right back in 2nd or 3rd grade. Solving equations, that's what you're doing here. Is you're saying something squared is 25. I'm asking you what fits in that box. You've got to be careful here. We know that 5 would fit in the box. 5 to the second power gives me 25, but is that the only answer? I know that 5 to the second power is 25, but is there anything else that I can square to give me 25? What's a negative times a negative? And a positive. So what's negative 5 to the second power? Also 25. Most of the time, quadratic equations will have 2 answers. Actually, if you want to get technical about it, they'll always have 2 answers, but sometimes those answers will be the same. So let's look at some problems now. N squared plus 4 is 40. The first way of solving quadratic equations, sometimes you can use square roots. Show you what I mean by this. Going by those same set of steps, if you have any parentheses, get rid of them. If you have any like terms, combine them. We have some like terms here. Plus 4 and 40 are like terms. So what I'm going to do is I'm going to leave my n's on the left side. I'm going to take that plus 4 and I'm going to move it over here by doing minus 4. Mark it out. I now have n squared equals 36. In order to get n by itself, okay, it's really what I did on that last problem without saying it. In order to get n by itself, I've got to get rid of the square. In order to get rid of a square, I come to the other side and I square root. To get rid of a square, we square root. Squares and square roots are opposites of each other. And you've got to be careful about something else. When you square root over there, don't just square root, but do plus and minus square root. And I'll show you why in just a second. So the squares go, and n is equal to plus and minus. Square root of 36 is 6. If you don't put that plus and minus out front, when you're asking yourself, okay, what square gives me 36? If you don't put that plus and minus out front, you only have one of your 2 answers. Yeah, we know that 6 squared is 36. 6 times 6 is 36. But we also, from what we just a while ago said, don't forget about that negative. Negative 6 squared, negative 6 times negative 6 also gives you that positive 36. Next problem, x squared minus 2 is 17. To get rid of minus 2, we move it to the other side. We now have x squared equals 17 plus 2, which is 19. A little bit different here. Because in order to get rid of a square, we're going to square root. I don't know what the square root of 19 is. So what do? I'll leave it. From the other day, check and make sure that it won't simplify. If that had been like the square root of 20, we could split it into the square root of 4 times the square root of 5. So simplify if possible. If it will not simplify, leave it. Leave it as a square root of 19. If you want an approximate value, just to where it makes more sense, x is equal to plus or minus. And that's what that little symbol means, the positive or the negative of the square root of 19, which is like 4 points. Maybe get a calculator there. Square root of 19, 4 point. Give me 2 decimals. 35. Notice my equal signs. I put an equal sign here because remember we talked about the other day, exact versus approximate. Square root of 19 is exact, 4.35 is rounded. You will never be able to write the exact digits because the square root of 19 is an irrational number. Okay, another one? What would you do first here, Jackie? There you go. And minus 5 and 607, those are like terms, right? How do I move minus 5, Jackie? Good. So we got plus 5, so now we have 612. Is there anything else that we can move? Ethan? That's all of our like terms. But I've got something else I could move over. I'm going to get R by itself. Ethan, how do I get rid of the 9? Good. And as everybody see, it's pretty much the same thing as linear equations. Up to this point, you solve it just like a linear equation. So now I have r squared equals, go watch this. You don't have to use your calculator. 9 will go into 61 6 times. That gives you 54. 61 minus 54 is 7. So I'll put my 7 right there. 9 will go into 72. There's another way to divide it. R squared is 68. One more time, Nicole, how do I get rid of the square? What do I do for the other side? Good, and plus and minus as well. Plus and minus the square root of 68, don't circle. All right. Square root of 68 will simplify. I know the square root of 4, I know the square root of 9, I know the square root of 16, 25, 36, and let's see, 36 and 49 and 64. There's a perfect square root in 68. One of those that I listed, 4, 9, 16, 25. Anybody tell me which one is located in 68? How do I find that out? You take out your calculator, and you take 68. And the square root that you know, I know the square root of 9. I know the square root of 16. I know the square root of 4. Which one's located in 68? 4. I could split the square root of 68 into, plus and minus, the square root of 4 times, and when you divide it, then you get 17. So that means that 68 must be 4 times 17. Since I know the square root of 4, that's what we did the other day. Oops. Since I know the square root of 4 is 2, mark out 4, square root of 1 foot of 2. So 2 root 17. That's exact. That's reduced. Again, that's like leaving your answer as 3/6 instead of reducing it to a half. Go ahead and if that radical reduce it. Just a reminder, the square root of 68 and 2 root 17 is the same thing. 2 root 17 means 2 times the square root of 17. If you did the square root of 17 multiplied by 2, you're going to get that 8 point something, same thing as you do with root 68. Now, the other way of solving. Why do we need another method? Okay, look at this example. From what we just did, I'm trying to get x by itself, and well, we got an issue here. There's 2 x's. There's an x squared and there's an x. A lot of people say, put them together. Anybody see an issue with that? Yeah, they don't have the same x. Those are not like terms. X squareds will not combine with x. Okay. Squares will not combine with first powers. Third powers won't combine with second powers. Okay, those aren't like terms, so we need another method. Because if you try to move this over, and then how do you get rid of the 5? You divide, because that's not going to find. There's just all sorts of issues here. So here's your other method. Tell me something. You have some number, and you got some other number, and they're being multiplied together. Be it 2 and a 3, a 4 and a 5, 7 and an 8. But when I multiply them together, I get 0. Rachel, if two numbers multiply together, A times B is 0. Tell me something about those numbers. Rachel. One of them 0. Has to be. Is there any way you can multiply two numbers together to get 0 without one of them being 0? No, absolutely no way. Could they both be 0? Sure. Okay. 0 times 0, that's 0. 0 times 7, 7 times 0, 3 times 0, 0 times 3. That multiplies to give you 0. So, by the way, that's called the zero product property. Look at this problem here. X plus 3. There's no symbol between those, but that's times. X plus 3 times x minus 2 equals 0. If two things multiply to equal 0, one of them's got to be 0. So we're solving this equation before we get into the next step. We're solving this equation to show you how to solve the other equations. So if these two things multiply to give you 0, we know one of them has to be 0. So how many different answers do we have here? 2. If two things multiply to give you 0, set them each equal to 0 because one or the other is 0 and solve it. How do we solve it? Combine like terms. Move the 3 over, move the 2 over. To move over 3, we do minus 3, mark it out. To move over minus 2, we do plus 2, mark it out. So x is either negative 3 or positive 2. And you can check that. Plug in 2. You get 2 plus 3, that's 5 times 0. Is that 0? Sure. Plug in negative 3, you get 0 times negative 5. Is that 0? Yeah. Okay. So any questions about that? X squared plus 5x plus 6 equals 0. The problem we just worked had two things that multiply to give you 0. These are not being multiplied, they're being added. There's 3 things being added, not 2 things being multiplied. So we've got to somehow take x squared plus 5x plus 6 and turn it into things being multiplied instead of things being added. That process is called factoring. Taking something and breaking it into products. Breaking it into something times something instead of something plus something. Here's how you factor. This is what's called a quadratic trinomial. X squared plus 5x plus 6. The reason it's called a quadratic trinomial. Well, first off, I told you what quadratic meant. Second power. It's called a trinomial because it has 3 terms. A binomial has 2 terms. A monomial has 1 term. So this is a quadratic trinomial. And these are really easy to factor. Anytime you have a quadratic trinomial, it factors into the product of 2 binomials. And here's how you factor. First step is you ask yourself what multiplies give you x squared, and honestly most of you just get into the habit of just saying x. You'll just go ahead and put those there. That's why you put them there, because they multiply to give you x squared. Your next step, the most important one, you ask yourself, what adds to give me whatever the number is in front of the x? What 2 numbers add to give me 5, and those same 2 numbers must multiply to give me 6? Now here, let's discuss that. 2 numbers that add to give me 5, multiplies to give me 6. One of them's a really long list, and the other one's a short list. If you start here, all the numbers that add to give you 5, well, 0 and 5, 1 and 4, 2 and 3, 3 and 2, 4 and 1, 5 and 0, 6 and negative 1, 7 and negative 2, 8 and negative 3, 9 and negative 4, 10 and negative 5, 11 and negative 6, 12 and negative 7. It's actually an infinite list. Let's start over here. Okay, that's what we do. The numbers that multiply to give me 6, what are they? 2 and 3, 1 and 6. Done. And you could throw the negatives in there. Negative 2, negative 3, that gives you that. Negative 1, negative 6, that gives you that. So that's a really short list. So always start over here. If you need to, make your list down here. 1 and 6, 2 and 3. I need those same numbers to add to give me 5. What are they? 2 and 3. Positive 2, positive 3 is factored. You're done. Just in case, let me remind you how to check this. It's called FOIL. Let's make sure that this multiplies together to give you this. The way that we multiply these together, we take our first term, x multiplied by x gives me x squared. X multiplied by 3 gives me 3x. Done with x. Take your second number, or second term, 2. 2 multiplied by x gives me 2x. 2 multiplies by 3 gives me 6. These combine to give me 5x. Yeah, that checks out. So now with all that said and done, let's go back to the problem up here. X squared plus 5x plus 6 equals 0. Step number 1, your second method of solving quadratic equation is by factoring. We take x squared plus 5x plus 6, and we're going to break it apart. And that's what we just did. X and x. Two numbers that multiplied or add to give me 5, multiplied to give me 6 was a positive 2 and a positive 3. That's just like the last problem. Because JC, if two things multiply to give me 0, what must be true about one of them? One of them is 0. So either x plus 2 is 0 or x plus 3 is 0. We solve each of those by moving the 2 over, move the 3 over. I get x is negative 2 or x is negative 3. Two solutions. Quadratic equation. Quadratic trinomial equal to 0. Same set of steps. First off, something I guess I need to tell you. Make sure that it equals 0. You don't want it to equal 5 or equal 6. You want it to equal 0 because of that whole 0 product property. If two things multiply to give you 0, then one of them must be 0. So make sure first step that it equals 0. Next step, let's factor this. X times x gives me my x squared. And now the two questions again. I need two numbers that add to give me negative 3, but don't start there. Add to give me negative 3, and those same two numbers must multiply to give me negative 40. And y'all have me make a list, so I won't have to call it. Multiplies give me 40. Let's do a short list here. What's some things that multiply to give you 40? 4 and 10, good. Now stop that. Let me show you a trick. If you can't think, all you can think of is one thing, and that's it. Let me show you this little trick that I do. I call it double half. Double this one and half this one. Double this one and half this one. It works for the same. Or you could multiply this one by 3, divide this one by 3 if possible. You can't divide that by 3, right? I can divide that by 5. So you can multiply this one by 5, divide this one by 5, and you get a whole list of things. Try the double half. Double this one, half that one. Is 8 times 5, 40? Yeah. Double this one and half this one. That's 2 and 20. Does that give you 40? Yeah. Is that a long enough list? Sure. Now, last year you learned all these rules. I don't teach the rules. I teach rules for positives and negatives. Does everybody know what a negative times a positive and a negative times a negative is, right? A negative times a negative is a positive. A negative times a positive is a negative. So if we're looking for two numbers that multiply to give me negative 40, doesn't that mean that one of these has to be negative and one of them has to be positive? Right? So keep in mind, in my list, it's either negative 4 and positive 10 or negative 10 and positive 4. Negative 8 and positive 5 or negative 5 and positive 8, and so same thing down here. Now, these two numbers must add to give me negative 3. Out of those three, which one can I use to get a negative 3? The 8 and 5. Why? Because the difference between 8 and 5 is 3. Now, I need a negative 3, so is it going to be negative 8 and positive 5 or negative 5 and positive 8? Negative 8, positive 5. For this reason. Let's go, and I know we're going way back in algebra now. Let's talk about how you add, subtract positives, negatives, if you don't remember. A negative 8 and a positive 5. You owe $8. That's debt. Okay, a negative and debt, same thing. You owe somebody $8. How much do you have? 5. What does that mean? If you owe $8, you're still in debt. Okay, you're still in negative. You're still in the red. You owe $8, you have $5. So how much do you owe now? So negative 8 and positive 5 is a negative 3. Right? Isn't that what we needed? Negative 3. So, as give me negative 3 multiplies give me negative 40 be a negative 8 and a positive 5. And JC told us a while ago if two numbers or two values multiply to give you 0, that one of them has to be 0. Solve for x, move 8 over by adding, move 5 over by subtracting. Finish. Problem? X squared minus 8x plus 12 equals 0. Again, we can solve this by factoring. We need two numbers that add to give me negative 8 and multiplies to give me a positive 12. Adds to give me negative 8, multiplies to give me positive 12. Erica, give me a list of stuff that multiplies to give me 12. Good. And you could use the double half thing there if you didn't know, but give me one more that multiplies to give me 12. Double half, good. 6 and good. And that's long enough list. We can use those. But I got an issue here. Because I need it to add to give me a negative 8. That adds to give me 7. That adds to give me 8. I need to multiply to give me a positive. Well, that's odd. Those do multiply to give me positives. Does everybody remember that also negatives times negatives also give you positives? So in order to give you a negative when you add it, they both have to be negatives. In order to multiply to give you a positive, then they have to have the same sign. Either it's negative, negative, positive, positive. So that scenario works. Now think about what I told you a while ago about adding. Negatives are debt, positives are money. So here you have debt added to more debt. So negative 3 and negative 4 add to give you negative 7. You're in debt even more. Negative 6 and negative 2, you owe somebody 6, you owe somebody else 2. You owe a total of 8. So negative 6 and negative 2 adds to give you negative 8, multiplies to give you a positive 12. Kyle, if two things multiply to give you 0, then what must be true about one of them? Perfect. So either x minus 6 is 0 or x minus 2 is 0. Solve each of those, Carson. If x minus 6 is 0, we got to solve that by moving the 6 over. What do you get for x?
Negative 6.
Careful. It becomes, good. And this one becomes, minus 2 becomes, plus 2. I know, it is very early. So your answers are positive 6 and positive 2. And you can check that. What's this? Plug in 6. 6 to the second power is 36. Minus 48 plus 12. 36, let's go ahead and do the plus 12 is 48. 48 minus 48 gives you 0. Checks out. This problem looks the same, but it is 100% completely different. When there is a number out front, here's the issue. Is it x and x? No. It would actually be 3x and x, wouldn't it? What multiplies give you 3x squared? That's an easier one because you're pretty limited. Okay, if it's a whole number, it's going to be a 3 and 1. That multiplies give you 3. The method that we used to use when I was in school was called trial and error. And you never want to hear the words trial and error in a math class. Because trial and error means you try something, and if it doesn't work, you try something different. And if that doesn't work, you try something different. And if that doesn't work, you try something different again. And you could use an entire sheet of paper to try to figure out how to factor this. There's a new method around. And this new method is what's called bottoms-up factoring. You might have learned it in algebra once. Y'all do any bottoms-up? Y'all remember this stuff? Don't remember? Maybe. Here's when you use bottoms-up factoring. If there is a number out front in front of x squared besides 1. There was 1s before. That's what we've been doing. If there's a number that's not a 1 out front, here's how you factor these things. First step, you take that number and you move it to the end. Take the 3, move it over to the 5, and multiply it. Now let me say something. What we just did is not legal. That's not something that you can just do for the heck of it. Okay, that's not, there's no rules in math that says, oh, just take the 3 and move it to the end. There's no rules in math that states that. This is a shortcut. Okay, this is just somebody who just was working, playing around with these and found out, hey, this works. But there's no rule in math that states that you can do that. Okay, now can we factor this? Yeah, that's what we've been doing. That's a whole lot easier. So we move it to the end, and then we factor like normal, x and x. We're good now because it's 1x squared. We ask ourselves what adds to give me 8 multiplies to give me 15. Destiny, what adds to give me 8 multiplies to give me 15? 5 and 3. Positive 5 and a positive 3. Everybody good with that? Now here's what you don't do. Don't stop there and solve it. Okay? You're using bottoms up factoring. You're using this shortcut, the special method. So you've got another step thrown in here. After you get it factored, the number that you moved, which was a 3, the number that you moved, let's put that back into the problem. Your factored out numbers here, divide them by that number. After you factor, divide by whatever number you moved. Just the numbers. Now we can do 3 divided by 3. That's good. That's pretty easy. That's x plus 1. 3 divided by 3 is 1. Can you divide 5 divided by 3 without giving me a decimal? Can't, can you? This is why it's called bottoms up. If after you divide, which by the way, if you can't divide, try to reduce it. 5 divided by 3, that won't reduce it. After you reduce, after you divide, if there's still a fraction there, you move the bottom, where do you think you're going to move it? Up. Okay, that's the reason it's called bottoms up. If there's anything left on the bottom, move it up front. 3x plus 5. It's factored. And I don't know if you've ever learned trial and error, but I promise that's a whole lot faster. That's much quicker. So now we're back to what we were doing a while ago. Stephen, if 2 things multiply to give me 0, then what's true? Thank you. So 3x plus 5 is 0, or x plus 1 is 0. And then you solve each and you're done. You have 2 things to move over. Make sure that when you're solving this is linear by the way, you just took a quadratic equation and you broke it into 2 linear equations. This one's easy. Plus 1 turns into minus 1. Make sure you change the signs, guys, and move across equal sign. Here, plus 5 turns into minus 5. Mark it out. Multiply by 3 turns into divided by 3. Mark it out. So x is negative 5/3. Here we go. 10x squared minus 9x plus 2. Brianna, one more time. What do we do first? And it became x squared minus 9x plus equals 0. Good. Next, we're going to factor that. Megan, x squared minus 9x plus 20 factored into x minus. So hang on. Well, factored into first x minus 5 and x minus 4. And then you divided by the 10. You went into that next step. Since you moved 10, you got to divide by 10. If it'll divide, divide it. If it won't divide, try to reduce it. And if it won't do either, then you're moving the bottom up. So divide, reduce, bottoms up. So first off, Sierra, 5 divided by 10. Will that divide? Or will it reduce? I'm sorry. How? What is 5 divided by 10? So careful there. 5 divided by 10. You can do, now you said 2, right? But 2 is actually 10 divided by 5. So 5 divided, you do it from top down. You have 5 pieces of candy, 10 friends, dividing. Somebody help me out. 5 divided by 10, is that? That's not 2, but it's 1/2. It won't divide, it will reduce. Okay. I think, so I lied to y'all. They both reduce. I said one of them divides, one of them reduces, but they actually just both reduce, I think. X minus 4 divided by 10 won't divide either. But it will reduce into bits. Now that we've got them reduced, now this is the whole reason it gets its name bottoms up. Whatever's on bottom, move it up front. The 2 moves up. The 5 moves up. Now we're ready to solve. If 2 things multiply to give you 0, then one or the other is 0. Now let's try to do 2 steps in our head. I want you to get used to, in a 2-step equation, which is what this is, all you got to do is combine like terms and then divide by what's left. Combine like terms, divide by what's left. So we're going to take -1 to the other side by doing +1, and then we're going to divide by what? Good. So x equals 1 divided by 2. You can't divide that. Move the -2 over by doing +2 and divide by the 5. So -2 becomes +2, and you can't divide by 5, so we're going to leave it as 2 divided by 5. Now let me show you something. In bottoms up factoring, you can actually, you see that you could have got your answer from there? Yeah. In bottoms up factoring, here's your answers. X minus 1/2, go ahead and set this equal to 0. That's legal. But if I just asked you to factor it, you would have to do that extra step. This is the factored form, but set x minus 1/2 equals 0. Move that over. Don't you get a half? Set x minus 2/5 equal to 0. Move the 2/5 over. Don't you get 2/5? Okay? So you could get your answers from here, but that's only when you're solving equations. If I'd asked you to just factor, don't solve the equation, just factor, you would have to go that extra step. I'll work this one through myself. Just as a reminder, I won't ask any questions. I just want you to watch. Okay? You can take it down notes if you need another example, but we're doing the same thing. Bottoms up factoring. Step 1, if it's out front, move it to the end. So we now have x squared plus 5x minus 24. And what I would do is I'd follow along in my head just to make sure it makes sense to me. Now, if there's no number out front, if it just looks like this, it's easy. Just factor, set of h equal to 0, done. Solve it. We factor what's left, x and x. We ask ourselves what adds to give me 5, multiplies to give me negative 24. And I know for a fact it has to be a positive and negative. There's absolutely no way you can multiply to give you a negative without one of them being positive and one of them being negative. Adds to give me 5, multiplies to give me 24 would be a positive 8 and a negative 3. You have $8, you owe $3. That means you have $5 left. The number one mistake people make is they stop there, they set h equal to 0, and they're done. But you can't do that. Since you moved to 3, that means you have to divide by 3. And again, you can get your answers from that. Bottoms up, that gives you 3x plus 8 times, that will divide x minus 1 equals 0. So, set each of them equal to 0 and solve them. You know how I do that? I don't write another line underneath that. I pretty much just cover this up and set it equal to 0. Move my 8 over, divide by 3, gives me negative 8 divided by 3. Move my, okay, now cover this one up. X minus 1 equals 0. Move my 1 over, you get 1. There's your 2 answers. The last way of solving the quadratic equation. What you can't factor? You could try, well actually on this one, I think this is factorable. Hang on, let me look at this. X squared plus 3x minus 18. Yeah, that's factorable, right? Positive 6, negative 3. That will factor. But what if I give you something that's not factorable? Look at this one. X squared plus 5x minus 10. What if you had to solve something like that? What multiplies to give you negative 10 and adds to give you positive 5? Nothing. The only thing that multiplies to give you 10 is 2 and 5 and 10 and 1. That's positive. And neither one of those adds to give you a positive 5. That is not factorable. What do I do when something's not factorable? I use what's called the quadratic formula, which is the third and final way of solving quadratic equations that we're going to cover. Write this formula down in your notes. X equals negative b plus and minus the square root of b squared minus 4ac, all divided by 2a. Called the quadratic formula. Okay, I noticed something about my formula. X equals, by the way, that's your answer. X equals 3, x equals 4. That's where the x is at. That's where the x plays a part in this formula. But I've got A's, B's, and C's over here. I got a couple of A's, got a couple of B's, and I got a C there. I need to know what is A, what is B, what is C. If you haven't noticed, every one of these problems, well, first off, they've been equal to 0. And you've had x squared stuff, you've had x stuff, and then you've had plus or minus a number. That is your A, your B, and your C. Not the x's, leave the x's off. The A here is 2, the B here is a positive 3, and the C here is a negative 9. That's A, B, and C. So pretty much, how do you solve using the quadratic formula? You take that A, that B, and that C, and you plug it in this formula, and it tells you the two answers. Is it easier than factoring? Probably not. Because if you get pretty good at factoring, you'll get to where you can factor and go straight to the answer. So honestly, factoring is the best method. Quadratic formula, I feel like, is the next best method. Okay, I want to teach y'all something. First step, when you're using the quadratic formula, always do b squared minus 4ac. Y'all see that inside here? This is called the discriminant. B squared minus 4ac is a discriminant. It tells you how many answers you have. And more than that, help me with this. Square root of negative 4. Anybody know what the square root of negative 4 is? A lot of people say, oh, it's negative 2. I thought the square root of 4 was both 2 and negative 2. Was it not? So find the square root of 4. Well, 2 times 2 is 4. Negative 2 times negative 2 is also 4. So what multiplies to give you negative 4? Can you think of anything that there's not anything, right? Oh yeah, 2 and negative 2. No. A square root is what multiplies times itself to give you that. So, which, I'll go ahead and tell you, it's an imaginary number. We'll talk about imaginary numbers later on in algebra 2, and I'm not joking about that. It actually is called imaginary numbers. You do have an imaginary answer here. It kind of looks like a unicorn, but we'll talk about that in algebra 2. The square root of negative 4, pretty much in your real realm of numbers that you've discussed thus far, does not exist. So why do we do b squared minus 4ac first? What if that's negative? The square root of, if you get a negative number for b squared minus 4ac, you know what you can do? You can stop there and say there's no answer. So that's the reason you do it first. Is so that you know, am I even going to have an answer? Do I need to waste my time doing all that other stuff? Because if I do this and it's a negative, there's no answer, I'm done. So now with that said, let's try this. Let's first work b squared minus 4ac. And here's how I do it. I go ahead and do b squared first. B to the second power, because order of operations I have to anyway. B to the second power, since b is 3, 3 to the second power is 9. And I put my minus there, the minus for my formula. And my next step is I always do 4 times a times c. 4, and you can type it in your calculator if you need to. 4 times 2 times negative 9. 4 times 2 times negative 9, what does it give you? Negative? Good. So b squared minus 4ac is 9 minus negative 72, minus minus, that's a plus, gives me 81. So since my discriminant is positive, I can finish the problem now. And you just did the hardest part of that whole problem. Once you get b squared minus 4ac out of the way, the rest of it's easy. So x equals, let's do the rest of the formula, negative b. B is 3, see right there? Plus and minus, okay, let's think. I just worked out b squared minus 4ac, it's right there, it's 81. Could you save yourself a step by going ahead and doing the square root of 81? Is 9. And like I said, this was the hardest part, hands down, hardest part. So the square root of b squared minus 4ac, that was the square root of 81, which is 9. Okay, all divided by 2 times a. 4. A is 2, so that's 4. There's your two answers. Now let me show you how to get it from that. This symbol, once again, means positive or negative, means plus or minus. That's two answers. Your first answer is negative 3 plus 9 divided by 4. What is that? Negative 3 plus 9, and that's 6. And so many people will stop there and they'll type in 6 divided by 4 into their calculator. I don't want you to do that. Because 6 divided by 4, is that one of your division problems that you learned back in 2nd, 3rd grade? 6 divided by 4? No. 6 divided by 4 is going to give you a decimal. So since it's going to give you a decimal, stop, and instead of putting 6 divided by 4, treat it like a fraction. 6 divided by 4 is a division problem, or it's a fraction. Take 6 divided by 4, reduce it, and you get 3/2. 6 divided by 4 reduces to 3 divided by 2. Okay, now that's your first answer. Your second answer, okay, that was the plus. Now let's do the minus. Your second answer is negative 3 minus 9 divided by 4. So we can divide that one. Negative 3 minus 9 is negative 12. Negative 12 divided by 4 is negative 3. There's the second answer. Those are not irrational answers. When you have nice, clean answers like that, like fractions and whole numbers, you know what that actually told me about that problem? It was factoring. Okay? You didn't have to go through, if you like factoring, okay, if you don't mind factoring, you don't have to go through that. You could have worked that exact same problem this way. Make note of what your two answers are because I'm going to fly through this. Okay? Move it to the end. X squared plus 3x minus 18 is 0. Factor gives you x plus 6, x minus 3. Divide by the 2 that you moved. Gives you x plus 3 and 2x minus 3. Set them each equal to 0, you get negative 3. Move minus 3 over by doing plus 3, divide by 2, and you get 3/2. You could have solved it also by factoring. Okay. Some you won't be able to, that's what we'll talk about next time. Some you're not able to solve by factoring, so sometimes you have to use that formula. Anytime you're looking for an answer, you can always use not only factoring, but also what we call the quadratic formula. Negative b plus or minus b squared minus 4ac all over 2a. When you're given a quadratic equation, again, a is whatever's in front of x squared. There's understood to be a 1 there. B is whatever's in front of x, and C is whatever number is being added or subtracted at the end. So A is 1, B is negative 8, C is 12, and we just plug that in. And reminder, we always plug into B squared minus 4AC first. For the fact of, if you get a negative right there, you're done. No solution. B squared minus 4AC, help me with this. Claudia, B squared. What is negative 8 squared? Close. Positive. Because negative times negative be positive. And I go ahead and put my minus there. Now I've got to do 4 times A times C. Stephen, 4 times A times C. A was 1. C was 12. 4 times 1 times 12. Stephen, what do you get? Not here. Vanessa, do you get it?
Can you repeat that?
4 times 1 times 12.
I got 48.
48. So we get 64 minus 48, which is 16. B squared minus 4AC is 16. We're not done. That's leading up to our answer. Now let me show you something else. And this is kind of helpful. Is there something special about 16? Notice where that's at in your formula. Oops, I forgot the square root. There's a square root over the top of that. B squared minus 4AC is what I call the discriminant. The discriminant is always located under the square root symbol. What's special about 16? It is a perfect square root. We know the square root of 16. You know what that tells you about this problem? You could have factored it. Anytime you get a discriminant that you can find the square root of, that problem would have been factorable. Okay, and you could have worked with the other method. Now, but honestly, since you've gotten this far anyway, I'll just finish it up using this method. So here we go. X equals negative b. That is negative, negative 8. Two negatives make a positive in math. Not in real life. Not two bad things. I think it's going to turn out good. You have the square root of what is 16 underneath there, which is 4, over 2 times a, 2 times 4, which is 2. Those are two answers. And again, we arrive at two answers because of the plus minus. Your first answer being 8 plus 4 divided by 2. Your second answer being 8 minus 4 divided by 2. My first answer, 8 plus 4 is 12 divided by 2 is 6. Second answer, 8 minus 4 is negative 4 divided by 2 is negative 2. That's the exact same two answers you would have got from factoring. Correction. 8 minus 4 is not negative 4. 8 minus 4 is positive 4. 8 minus 4 is positive 4 divided by 2 should be a positive 2 though. I did that for a reason. Not really, but we'll go with that. What I did is I looked up there and I actually factored in my head. And I said, you know what, x squared minus 8x plus 12, that's going to factor into, and that's how quick factoring is, solving it by factoring. Adds to give me negative 8, multiplies to give me positive 12, that's negative 6 and negative 2. So that factors into x minus 6, x minus 2. Move your move your minus 6 and your minus 2 over. Both of those answers should have been positive, so that's how I caught that. Okay. Let's work another one. Let's try this one. And again, we always start out with b squared minus 4ac. And that's actually also going to tell you if it's factorable. If you can solve it by factoring. Abby, what's b squared? Good. Minus. The minus is built in. 4, Ethan, 4 times a times c. What do you get for 4 times a times c? 60. 64 minus 60 is 4. Your discriminant is equal to 4. Would that be factorable? You know the square root of 4? Sure. Yeah, you could have factored that. We actually solved it by factoring the other day. Something else, I wrote this down for a reason. If you don't know what 12 times 5 is, that's fine. Why not do 4 times 5 is 20 times 3? Remember that multiplication is commutative. You can multiply, that's your algebra tidbit for the day. You can multiply in any order. That's the commutative property of multiplication. What if I don't know that, but I do know 4 times 15? That's 60. So you multiply in any order you want to. So now we have our formula. X equals negative b plus or minus the square root of jump all over 2a. And the reason I put the square root of jump, there's jump over there. We've already done that. So plugging into my formula, negative b plus and minus the square root of 4 is 2 over 2 times 3 is 6. There's your two answers. The first answer being negative 8 plus 2 divided by 6. The second answer being negative 8 minus 2 divided by 6. Negative 8 plus 2 is negative 6. Negative 6 divided by 6 is negative 1. And my second answer is not going to come out so nice and neat. Negative 8 minus 2 is negative 10 divided by 6. And negative 10 won't divide by 6 without giving you a decimal. We don't want decimal answers. We want nice, neat fraction answers. So since that won't divide, again, remember division and fractions are one and the same. They're identical. This is a division problem, but not only is this a division problem, it's also a fraction. So treat it like one. Since it won't divide, reduce it. Negative 10 divided by 6 is the same thing as negative 5 divided by 3.